today's topic, we are going to see about image classification. So, before that, have you all installed TensorFlow in your Ubuntu environment? I guess most of you are using Windows Jupyter Notebook. So, try to install it in Ubuntu as well and check whether it is creating any issue or not. Okay, in case if it is creating any basic issues means um, try to update your conda. Okay, like you can give like conda space update hyphen hyphen all. Okay, so check that and see once. Or if that is not working means instead of going for pip 3 install TensorFlow, you can try conda install TensorFlow. Okay, you check it and see whether that is working or not. If both of them are not working because of some dependency issue means you try to create some new virtual environment. Okay, you can easily create from Anaconda environment itself. So if you go to Anaconda Navigator means okay. Okay, because why? Because now if you are using Windows and then during the exam time you want to do it with Ubuntu or anything means at the time if you are not having properly installed libraries, then it is throwing any error means you will be in the trouble. So make sure you use both the environment parallelly. Okay. So here if you go to the environments column means basically you will have that base root environment. Correct. So you can create from here. Like if you give create means it will ask for name. Okay, and then Python, which version you want to choose for Python. Okay, it's suppose 3.8, 3.7, 6 is there. Uh, so in case if it is not working, TensorFlow 2 point some version is not working means make sure which Python version will support the package and you can give that particular version name and you can give name for that. It will create you one new environment for you, separate environment. In that you try to install your TensorFlow and check. Okay. Because in 3.9 the older TensorFlow version may not be working. So in that case you can go for older version Python and then you can create your environment. So after creating your environment, if you go to your terminal means by default you will have the uh, base environment, right? So simply by giving conda deactivate that will be deactivated. Okay. And then you just have to activate the new environment you created. Okay, just by giving conda activate and then the environment which you have created, what name you have created that you can give. Okay, try and check it if in case you are getting any error. Okay. Okay, so let's try to go back to the topic. So in today's topic, image classification, we are going to see it is not going to be like actual image we are going to take and then process it. Instead, the weights, the pixel values of the image will be taken in a CSV file, and based on that, we are going to find okay what type of image it is or what class it belongs to. Okay, so if you see the left hand side input images means this is how our image is going to be looking like. Okay, so totally we will have 70,000 images. From that 70,000 images, 60,000 will be taken for training and 10,000 will be taken for testing. Okay, each image size will be of 28 into 28 grayscale images. So these are the grayscale images which will be in numerical format. Okay, for each pixel they will have some values, right? In that way, it will be stored in our CSV file. And the classes which we are going to have or which we are going to predict is we are having 10 different classes. Okay, so these images, if you classify, yes, yes, anyone? Okay, so this is how the input is going to be, and based on the classifier, okay, CNN method, we are going to find which class it belongs to. Okay, so if you take this particular image, means this comes under sneaker class, correct? So similarly, this comes under ankle boot, and this comes under t-shirt. In some cases, this type of images can be wrongly predicted as uh, pullover or shirt. Okay, because both will be looking more or less similar, right? So some that type of error can be possible. So and this comes under bag category. Okay, so like this we are going to find the category of our uh, image. Okay, so as we know, 28 height is there, and 28 width is going to be there. Okay, so if I multiply, means we will get 784 784 pixel we will get. So for each pixel we will have one column. Okay, so here if you see, means 784 is there, starting from first pixel to 784 pixel. Okay, and each value will be filled by 0 or which value is there. So the values are going to be ranging from 0 to 255. Okay, so 0 represent black color here, and 255 represent our white color. Okay, so totally 784 columns. Okay, so after that, what in the convolution neural network CNN, what we are going to do is those images will be passed to our hidden layer, like neural network, and that is going to predict our class. Okay, which class this particular image belong to. Okay, we may be randomly taking one image and then passing, or during the testing time, it will try to predict each of the images. Okay, whether it is matching or not. If it is matching, means that class we will get as output. Okay, but before going to this stage, what we will do is first we will take the image. Okay, that image will be passed to an convolution layer. Okay, so in this layer what will happen is the feature detector will happen. Okay, feature detector is nothing but taking the image and trying to find the sharpness, blurriness, so many factors it will try to check. And then in the next step, following that convolution layer, we will have the polling layer. So here what will happen, the entire image will be converted into some small image by taking the highest value from each matrix value, like how we have seen in examples. Like I have also told, like cycle is there, and each feature it will try to extract, and based on that it will come to a conclusion whether this comes under any other class or not, instead of checking the entire image. Okay, so that is what going to happen here also. So entire image is going to be there, some feature extraction will happen, and then those from those feature extraction, so it will create some smaller image by taking the maximum value out of it. Okay, some new matrix will be there, and here we will be using the ReLU function method. Okay, so and then those matrix values will be converted into flattened images, like it will be converted into array format, and those will be passed as input to our hidden layer. Okay, after passing it to the hidden layer, so we are having 10 classes here, so we will create 10 output. Okay, in previous example and all we created dense one at the output stage, right? Here we will be creating 10 because of 10 classes. Okay, so in feature direction, so as mentioned here, they are taking the given image and then trying to perform some filtering operation. Okay, during that filtering, it will apply some effects such as blurring and sharpening. Okay, after that, it is going to take feature extraction by selecting most important pixels of an image. Okay, here most important pixel will be of this area alone, right? So only this area is important for us when compared to other areas. So likewise, it will start extracting the data. Okay, and then it will try to find the relationship between each pixel. So this is what called as feature mapping. Okay, let us see this with the example. So if you go to this particular website, let me Go to the okay, this is the website. Okay, image kernels. So how it is creating the image kernels, that simply you can see by visualization. Okay, here you cannot upload any new image. This is a sample image they have taken. This sample image has been converted into matrix format. So each matrix represent one pixel value. So you can see if I'm moving in the left hand side means it is showing right hand side which particular pixel it is representing. Okay, then this is the feature scaling feature. So here we have given it as sharpen. See, sharpen is there, outline, blur, lot of features are there. Here we are taking the sharpen method. So by this particular matrix, we will try to multiply with our actual input image. Okay, so if you see in the left hand side means 9, like 3 by 3 matrix has been taken. So from this 3 by 3 matrix value, see like in the middle you can able to see the values of inside the matrix, and then those are multiplied with the sharpened values which we have seen here. Okay, and based on that it is creating one output image for me. Okay, this is the polled image. Okay, polling, after doing the polling operation, this is going to be my output. Okay, likewise it will try to extract best features, and then based on this image only it will detect it is a person, or it is a dog, or it is an object. Okay, all this calculated by this method only. Okay, uh, okay, so here if you see means same thing, like here feature director has been taken, some random values here given. Okay, this values will be multiplied with our matrix, again 3 by 3 matrix we will take, and after multiplying we will get output as 1. Okay, because this 1 into this 1 into 1 only will become 1, all remaining values will become 0. Okay, so similar way it will go for next 3 by 3 matrix. Again we will get 1. Likewise, it will move to each 3 by 3 matrix, and then it will create one new matrix. See, feature mapping. It is creating one feature mapping. Likewise, after going through all the matrix stages, it is predicted this particular value. Okay. After this, what this relieve method is going to do. So we have seen the some introduction, right? What this relieve method will do. So if it is a positive value, it will keep it as it is. If it is a negative value, it will try to convert it into 0. Okay, here if you see the graph itself, you can see positive values like it will be raising, negative values it will not go for any negative value, instead it will convert it as 0. So this is what going to happen in our case also. In case if our matrix is having any negative values means those values will be replaced by 0 by our activation function. Okay, so and then we will go for polling method. So again, here we are going to take 2 into 2 matrix, right? So again here also we will take 2 into 2 matrix. From here we will try to get the maximum value. So out of this 4, 6 is the maximum value, and then we will go for next 4. Here 8 is the maximum value. Likewise, based on the maximum values, we will create one 2 by 2 matrix. Okay, then those matrix will be converted to flattening stage. Okay, now it is 2 rows, 2 columns. Now it is single column. Okay, then this will be passed to our neural network. So 4 columns is there means 4 input we are passing, like that assume. Like then 4 input will be passed to our hidden layer, and then finally we will get some output. Okay, to understand this even little bit better, we go for this website for visualization purpose. Okay, so if you go to this particular website means they have created already so this is going to be my input part, and then we will have some convolution. So here they have given it a little bit clearly. Okay, uh, if you go to this website means I think you can scroll down. I don't know, I cannot able to scroll it. So here if you see means they are having the input layer, and then the convolution layer, and then downsampling layer, which is going to reduce my image size. And then again they have created second convolution layer, downsampling layer, and then finally that will be converted into our hidden layer like flattening as happened here. And that values will be again passed to our second hidden layer. So finally we will have the output part. Okay, the output is nothing but 0 to 9 is going to be my output. Okay, I don't know, I cannot able to zoom it better. Any doubts is there? Okay. So here if I draw any numbers inside this particular black area means, then we can able to see how it is trying to process it. Okay, assume that I am giving 5. Okay, so if I'm giving 5 means, see if you see the output means only the 5 has been highlighted when compared to other values. So what is happening in the each layer if you see means, see here this is my input. Okay, that has been passed to my convolution 2D layer. Okay, here it is trying to extract some features. Okay, in each diagram you can see different ways it has tried to extract the feature. If you go to the next layer means, if you see this three thing means it is somewhat looking like this is this layer looking like 5, this and are looking like yes, right, somewhat looking like yes, this is looking like 3. So different shapes we are getting, and then those will be again further divided into multiple pieces. Okay, based on that it will try to predict the value. Okay, afterwards we have created multiple matrix. Those matrix will be passed as a flattening layer to our hidden layer, sorry, flattened, it will be flattened and then it will be passed to our hidden layer, and from that hidden layer another hidden layer will be there. So after that we are finally finding this predicted value will be 5. In case if I'm giving some complex value, or I'm giving like 6, or I'm giving 6 like this. As a human, we know this is a 6, right? It is little bit shaped in different direction. If you see from another angle means this look like 9. Okay, so as per our prediction, see our model predicted as first guess as 6 and the second guess is 8. So it is, there is some more possibility that it can be 8 also. Okay, like that it will try to predict. In some cases, if we are giving some complex number, I mean, in it is not recognizable format means it will predict two classes also. Okay, like as we have like I'm giving two like this means, see this also it has identified uh, very accurately. Okay, some people will have a habit of giving two like this. Okay, so my our model first guess is 2 and second guess is 1. Like this only the process is going to happen in our model elsewhere. Okay, in the backend we may not be seeing all these things visually, right? Okay. So how to improve the network performance? So here, as per the CNN, not only for CNN but also for other neural network, there is we will have some dropout values. So this dropout values is nothing but if you go to the previous example, if you see the flattened area means some areas will not be used or utilized by our matrix. Okay, those are simply there, and those are not very effective for our hidden layer. Like in case in the hidden layer we are having 100 neurons. Okay, all the unders are not going to be giving you the going for the next layer, right? In that case what we will do, we will try to reduce some count of our neurons in each epoch count. Okay, and then we will check whether any performance change is there or not. Okay, so if any good performance is getting means we can stop with that drop count. Okay, or else we can little bit increase to change our performance. Okay, that is one thing we can do. So another thing is adding filter. Okay, here we have seen only one filter, right? Filter here comes is two layer we will have. One is for convolution part and another one is for polling part. Okay, likewise you can create two, three like that you can create. Okay, or else you can increase the batch count also. Okay, instead of giving small batch count, you can increase the batch count. Like if you are giving 32 as your batch count means, you can give it as 64, 128, 512, something. You can increase the value and also check. Okay. Um, okay. So this is what the structure is. Input is there, hidden layer is there. Assume that 500 or 100 neurons are present in this hidden layer. Okay. Sorry. From that some layers, I mean some neurons will be removed, okay, after each epoch count. and then it will check whether it is giving good performance or not. If it is giving good performance means we will keep it, otherwise we will stop dropping the neurons from our neural network. Okay, and then finally we will try to find the confusion matrix. Okay, how much it has predicted correctly and how much error it has made. So this is what going to be the steps for image classification. Okay, so let us see that in practice. Just a minute. So are you all able to understand the like steps what we are going to do?
Understanding, can you please paste that URL in the chat box?
It is in the okay. I will paste both the URLs, right?
Parallelly, I'm also checking here.
Okay, you can. Okay, okay. Hope my screen is visible now. So here what I have, I'm going to do this particular program in Google Colab only. Why? Because the epochs will take a lot of time if you are doing it in your local system. Okay, to avoid that, I'm using it in Google Colab. Okay, if you want means you can use your normal Jupyter notebook as well. Okay, so what if you are trying to do it in Google Colab, like similarly how I am doing is, so better you try to, if you go to your Google Drive means you will find the Colab notebooks will be there. Inside that particular folder, you paste your training and testing CSV file. Okay, because this files will be little bit bigger in size. So first upload it, then you can use it in your um, notebook very easily. Okay, so I've already created the simple template. Okay, so the problem we have already seen. So 70,000 image weights are going to be there in our CSV file. In that 60,000 is going to be in our training CSV file, and then 10,000. Okay, I will change the theme and increase the size for you. Okay, just a minute. Okay, okay. I think this text, th this looks better. Okay, our problem statement is this. We are having 10 classes. Okay, 0 to 9, and each represent the what to say, the cloth name of the cloth. Okay, and then all this we all know, we have seen it. Okay, so in the first step, as usual, we are going to import the libraries. Okay, in Google Colab by default you will have the TensorFlow, okay, library, so you don't need to install separately as well. So that is one advantage of using Google Colab. Okay, and then I will import Matplotlib as well. Okay, okay. So mount drive I have given. Why we have to mount drive is each time when you mount the drive only you can able to access the files. Here you can see only the sample data only. If you are directly trying to copy your CSV file and paste it here means it will be pasted. Okay, if it is less size or big size, but it will be pasted for temporary purpose only. Okay, when you refresh your website or browser or anything means those data will be removed. Okay, each time when you are doing the um, working on this particular Google Colab means you have to upload each time. Okay, so that is one thing. Similar goes for a drive. If you are saving in drive means you just have to mount the drive alone, and then from there you can access the files. whichever present in your Google Drive. Okay, so for that you have to give from google.colab, so import drive and then drive.mount. So this is common for everyone. Okay, it will ask whether I have to connect with Google Drive or not. Just simply give okay, allow. Okay, now if I go and check means my drive has been added. So from that drive, I'm going to load my data set. So this is a fashion based data set. So I will give name it as fashion. For training separately, I will get so training data frame. So pd dot. So here try to give the full path. Okay, from content drive. So from that we will have my drive. Okay, cap small space everything should be same. Okay, and then collab notebook, sorry, collab notebooks. From that I'm going to take the fashion mist, I think my drive collab. So function minutes test is there, function minutes train csv file is there. Okay, so fashion. So similarly for um, instead of train I will give test. Okay, so both the data set has been taken. So now we will simply summarize and check. Okay, what are all the present in our data set? So fashion. Okay, before that I will turn on my GPU as well. Okay, we will be needing it in the later part. Okay, what is the difference between like using CPU and GPU is if you are using GPU in Google Colab means you can only open one col like one Jupyter notebook at a time. Okay, if you are trying to open or run another Colab means it will say manage your session like that. Okay, so here I will take like 5 values I'm taking. Okay, what I made the mistake is not defined. Fashion train. Okay, sorry. I have changed the GPU, right? So I have to run all these cells, previous cells. Okay, that is why it is showing error. For that, to making it easy, we can go to the runtime and we can give run before. Okay, or else we can give control plus F5. Okay, I'm just giving run before. So all the previous cells which are present will be running automatically. Okay, again it will ask for connection. Okay, so now if I run this means okay, it will run as expected. So here if you see means I'm having 5 rows, like 5 I have taken, that's why I'm having 5 rows and then 785 columns. So why we are having 785 columns? 784 is for pixel and the first column is going to be my label, which is the representation of the cloth. Okay, so 2 means that product name, like pullover. 9 means ankle boot, like that here we have mentioned. So this is going to be my y, and this all these are going to be my x value, right? So before that, what we have to do is we have to split it into training and testing. So for that we will convert this values into array type. Okay, because we have to convert it into flattening values, then only we can pass it into our hidden layer, right? So for that, training, okay, np dot array. Okay, I'm converting all of them into uh, array values. So np I have not sorry, I have not yet imported okay, only I have imported pandas. Otherwise here itself I will import, no issue. Import numpy, that's np. Okay, see, this will show some suggestion as well. Now I have to convert it into array. So what are the things I'm going to convert? Fashion. So I can also specify the data type as well. Okay, here I'm specifying it as float 32. Okay, same goes for testing as well. np.array. Okay. Okay. So this line has been completed. So if I go and check my shape means, so I'm having 60,000. As I mentioned, we are having 60,000 rows, and then 785 columns is there. Okay, same goes for testing as well. Okay, in testing we will have 10,000 rows and 785 columns. Okay, so this also we have created. So let us see some sample images, like how it is looking. Okay, like how we have seen in the PPT. Similar way we are going to see the images. If you go directly and check the CSV file means, as I told, it is going to be in the number format only. Like this only you are going to see. Okay, instead we are trying to convert this numbers into some image format. So for that, I will import random. Okay, randomly I will choose each time when I'm running this particular cell. Okay, so some I value. So random dot randint. Okay, totally we are having 60,000, right? So I can specify it as 60. So out of the 60,000, I'm going to take some value. Okay, as my I value. So based on that, I'm going to plot it. I have already imported my matplotlib. So from that, so training uh, I value, comma 1. So why I am taking it from 1? Because my zeroth column is going to be label column, right? So we don't need that column. And then I have to reshape it. So in what shape I have to reshape? 28 into 28. Correct. So that is what our image size is. Now let me run this and check. I hope it will work. Okay. Similarly, uh, wait, I will run this. Okay, the two value of array with more than one element is ambiguous. Okay, I think I should specify. Sorry, I should specify it as I am show. Okay, not like only show. Okay, so I got the sneaker. Okay, in case if you want to specify it in grayscale value means, simply you have to add CMap equal to gray. So that will show it in gray. Instead of showing like this, it will show it in gray. Okay, so this time I got some other cloth image. Okay, so how to identify what is the label of this particular image? So for that, you can simply uh, label. So I comma 0. So if I take 0th column means I will get the label, right? So I will display the label as well. Let us see. So for this label is 5. Okay, so 5 means here sandal. Okay, some ladies sandal I guess. Okay, like that it is showing. Okay, and the next step is instead of seeing it as this view, we will try to view the grid format. Grid in the sense, instead of seeing one images, we will try to see some 10 or 15 images at a time. Okay, more than like in rows and columns. So for that, what we can do is, so so let's view. Okay, for grid view, we need to specify the width and length of our grid. Okay, for that I'm simply giving as so W width of grid. So any values you can give. So I'm simply giving it as 15 and then L grid. Okay, 15. Okay. Then I'm going to take figure and axis value from subplot. Okay. So inside that I will pass the length. So length. So here also you can see like rows, how many rows you are going to pass, how many columns you are going to pass. Okay, like that is showing the description also parameters. So documentation also you can see. That is one advantage of Google Colab. Okay. So now I'm going to specify the columns, right? So for that W grid, and then finally I'm going to give the fig size. Okay. So again, this is also depend upon the value. So you can give any random square values. Okay. And then what? Based on this axis, we are going to convert it into. If I try to print this axis means, okay. If I try to print this axis means it is wait, it is printing like this, but I don't want to be like this. So I will convert them into. So we know what this Ravel method will do. Like this is similar like flattening method, right? So this is going to flatten flatten the 15 into 15 matrix into array format. Okay, and then we will create some for loop. Okay, here we got the empty cells. So here then we are going to fill the images. For that, for in np dot range starting from 0 and then with grid into length grid. Okay, so if I multiply 15 into 15 means you will get 225. Okay, so 0 to 225. Okay, so for that randomly we need to take some index, right? So np dot randint. So again 0 to length of our training data set. Okay, okay, and then finally we will try to or else I will specify the command so that you can able to understand. Selecting random values. Okay, from axis dot image show. Similarly, what I have done in the previous line, I'm just redoing it. Okay, so training. Okay, then we can give title as well. So for title, so we can specify the label values. Sorry. So index comma 0. Okay, and finally, if you don't want to specify the axis means simply you can remove the axis. Okay. Finally, I have to give it as subplots adjacent values. So okay, some spacing value I'm giving. Okay, how much space I want. See left h space means initially it will be none. So I have given it as 0.4. Let us run this and check how my output is coming. Okay. See, so it has randomly taken. So 15 into 15 means like 250 images it has taken. Okay, and the numbers which you are seeing in the top are the classification. Okay, value. Okay, 3 means that belongs to that category, 9 means another category. Like that it is showing. Okay, so similarly, now I will just, okay, up to this, okay, right? So now I'm going to split the data, like training data into X and Y and testing data into X and Y. Okay, so uh, for that, X train. So instead of going for scikit-learn model selection train split method, I'm just directly splitting them in this way. Okay, because we already have created the data. So just using that. Here only thing I'm going to do is I'm going to divide it by 255. Why? Because then only we will get some lesser value, right? If it is 255 means we will get 1, or in between value means we will get some point values for X train. Okay, so if you wait, I will just show that so that you will understand. See, the values will convert it into zeros, ones format. Okay, so that is why I'm giving like that. If I don't give, that means okay, inside it will have some actual values. So to avoid that, I'm giving the divide 255. Okay, and then same thing we will do it for test, but now I want y train. Okay, so so 0. Similarly, I will do it for y test. Sorry. For y test, I'm going to take it in the testing. Okay. So we have created it. Okay. So now if I go and check my shape means, so it is in different format, right? So I'm going to convert this 2 into like 28 into 28 into 1. So here 1 represent what? The channel value, right? Here we are taking the grayscale. So for grayscale, we will have the channel value 1. If it is a color image means we will have channel value 3. Like for RGB, we will have 3 colors, right? So for that, I will try to just for command purpose, I will try to unpacking the tuple. Okay. So now again, like I will update it in my training set and testing set itself. Okay. Train dot reshape. Okay. And then if I check x train dot shape of 0, okay, starting value, and then I will give 28 into 28 1. Okay. So similarly, I will do it for x test as well. Okay. So again, I will give x test dot reshape. Okay. Okay, where x is not defined. Okay, sorry. Okay. So now if I go and check my shape, so along with the 60,000, so the shape has been converted into 28 into 28. Okay, like image format. Initially it was 784, right? 785, and then we split it into now it is 784, and then one is channel value. Okay, so now we come to the building part. Okay, up to this, any doubt is there? We have done very simple things only. Just imported the library and then I mean imported the data set. Okay, in two different variables, and then using the numpy we have converted the dataset into array format. So we got 60,000 and 784 785. So same for training and testing, and then we will simply for checking we did some random values, and then we started creating one grid to see the multiple images, and afterwards we splitted the data into two halves, for training two and then for testing separated, like x and y values we have separated, and then we reshaped them into image format, so 28 into 28 format. So now we are going to build our model. Okay, for that, so from tensorflow dot sorry tf dot keras import. So what are all the things we need? We need the layers as well as models. Okay, so since I'm going to create some convolution neural network, I just give it as CNN. So why it is showing error? Okay, I think I should have give it as TF only. Okay, I think now the error will be solved. Okay, CNN is equal to, okay, this is just nothing but the name. Okay, you can give any name. Models dot again sequential. Okay, sequential. Okay. After that, what we will do? We will create the layers, right? So first layer, I'm adding. So layers dot, here we have to give it as convolutional 2D. Okay, so here we can see convolutional 2D is there. So that is what we are going to give. Inside that we are going to pass some values like 32, 64 and all we have seen, right, a batch counter. So here I'm going to give 32 as my batch count, and then I'm going to create 3 into 3 matrix. So similarly, whatever we have seen in the PPT, just I'm creating it as program. Okay, and activation function ReLU method I'm using. And since it is the first layer, I have to specify the input shape. Okay, shape is going to be in um, 28, 28, 1. Okay, so similar this shape only we are going to pass it. And next, following that we should have cnn.add max polling method we are going to use. Okay, so max polling 2D. Okay, so max polling 2D method, in that 2 by 2 matrix I'm going to take. Okay, similarly I will create another one layer as well. So here instead of passing it as 32, so I will change it as 64. Okay, and then finally I will create another one final convolution layer alone. Okay, uh, and for this layers we don't need to specify any input shapes, only for first is enough. I will just remove them. Okay, so this final convolution layer is going to pass to the next layer where it will be flattened. Okay, okay, after flattening it we have to pass it to our hidden layer. Okay, otherwise I will initializing the model first, and then we are going to create hidden layer. So in hidden layer I'm going to get it as 64. Okay, so activation is going to be my ReLU method. Okay, and in my final layer, output layer, so cnn dot add, here I have to specify 10. Okay, 10 classes activation. So here what method we have to use? Softmax method. So we have seen the softmax method, right? So that only we will be using for convolution type of problem. Okay, so finally we can check the summary also. Okay, so here all the layers has been specified in the left side column and how many outputs we are going to get and final output counter. Okay, so next what we have to do? We have to compile our model. So for compiling, cnn.compile. Here, previously we have seen two losses, right? One is for mean square error for regression type we have seen, and then binary uh, cross entropy method we have seen. So binary cross entropy method we cannot use here. Why? Because here we are having more than two class. Okay, so for that we are having separate one loss finding method that is called pass. Okay, categorical cross entropy. Okay, categorical cross. Okay, and then optimizer we are going to use Adam only. And finally metrics, I want to check accuracy also. Okay, so okay, this is also completed. So here comes the epoch history part. So we will create epoch history. So CNN dot fit. So X train, Y train, batch size I'm giving it as 512. So what will happen? How many rows is there? That will be divided by 512. So based on that, batch will be created. Okay, and then epochs. So initially I'm giving it as 20 epochs. Okay, later we will see any changes there or not. So this will take some time. Okay, okay. If you are doing it in your local system means even completing the first epoch itself, it will take a little bit more time. Okay, so let this 20 complete. So we can also able to see like started with 69% accuracy. So slowly our accuracy start getting increasing. Okay, in the meantime, we will try to run the remaining, I mean, we will type the remaining code. Once this completed, we will run this code and check. Okay, so after epoch, what we have to do? We have to try to predict the value, right? So prediction. So for that, y predict cnn.predict. Okay, test value I am passing. And then, um, okay, here one more thing we have to do. Okay, because why? Because if I check the y predict value means it will be in some array format. Okay, otherwise, okay, I think epoch counts has been completed, I guess. 20 out of 20 came. Okay, finish. So now it will be better to run this. Okay, see here output is in some array format. Like if you go for each column also, like it is having multiple values in it. Okay, based on this we cannot able to perform confusion matrix or accuracy score. So for that we will be going for one more step. Okay, nothing but we will find the maximum value out of this particular array. Okay, for that, okay, predict, I will create one variable and store it. So predicted. So previously we had another one method. Okay, predicted classes itself. If you are doing here means the output will come directly, but now in the sequential method that particular method is not supported. So that is why we are doing this one more step. Okay, so predicted classes equal to np dot, so we are trying to find the maximum argument. Okay, so I will pass the y predicted value and axis equal to 1. Okay, so now if I go and check my predicted classes means, see, it has been converted into 0, 1, 2, 8, 1 like that. So our y test value also going to be similar like that, right? See, that is also in some format. So based on this, we can able to easily compare the values. See, now itself we can say 0, 1, 2 is there, 0, 1, 2 is there. So lot of I mean matching is more. Okay, so let us find it by evaluating the model. Okay, so before that, if you want to see, okay, how we have seen in this image, we have seen the class, right? Similar way, you can also find what is the predicted class and then what is the true class by using this mapping method. Okay, for that, I will simply copy this. Okay, we don't need to check for all the values, right? So I will reduce the grid size like, okay, let us take 5 values. Okay. Um, I will change the variable also y l. So here also I have to give it as okay. So then here also I have to change. Sorry. And then okay. Here instead of giving title like this, okay. So I will give it like can give it in a f string method or dot format method. So I will give it in dot format method. So predicted class 0.1 f, and in the next line I will print the true class, which means actual class, and then dot format method predicted classes. From that I have to get the I value. Similarly for y test. Okay, so others remain the same. So let us see how the output is coming. See, here if you check means how, see, the predicted class also 0, the true class also 0. So most of here this is not matching. So the predicted class is 6, the true class is 2. Let us see what is 6 and 2. So 6 is shirt and 2 is pullover. So I have in the beginning itself I have told, right. So it will get confused with whether it is a t-shirt or a shirt or a pullover. So as per our model predicted it as a shirt. Okay, but it is actually a pullover. Okay, I think some jerkin kind of thing, I guess. Okay. Mm. So if you see any other mismatches there. Here another one mismatch is there. So predicted class is 2 and the true class is 4. Maybe it might have confused with shoe and sandal something, I guess. Or else wait, I will copy this.
Ankle boot, I think.
Yes. Yes, yes. No. 4 and wait, I will copy this. So easy for me to compare. Maybe similar like that only, right? Sorry. Okay. Now little bit easier to compare. Okay. Here 2, 4 is it. 2 is predicted, 4 is actual value. So 4, here itself, the data itself I think wrong. True value itself it's showing 4, which is wrong. So that is why our predicted value is also wrong. Okay. And then which means the data is not clean. Okay. The labeling has not done properly. and I think all others have predicted exactly. Okay, one or two mismatching only is there. So we can find the confusion matrix and accuracy score, and then we will check how it has predicted our value. Okay, from sklearn. Okay, so how we will find the confusion matrix? Just confusion matrix. Okay, so this is our confusion matrix. Okay, let us check the score of it. I mean, by finding the accuracy score. Uh, okay. So my accuracy score is 0.91, which is 91 percentage. It is predicting correctly. So if I increase my epoch counts means, so my performance also will increase. Okay. Uh, if you are giving going for 50 or 100 means, you can see accuracy of 9 more than 9 95 99 like that also you can get. 97 you can get, or more than that also you can get. Okay, if you are going to practice this particular program means, try it with Google Colab only. Okay, because this epoch count will, I mean, if you are increasing the epoch count means, it will take lot of your time. Okay, here I am using the GPU, that is why this process has been completed in less number of time. Okay, so that is only thing. So I'm just for giving it as 50. Okay, okay. Up to this, any doubts is there regarding the image classification type of problem? Similarly, there are some other data sets also available in the kaggle.com, like traffic signal based programs and all is there. If you want means, you go and check it out. Okay, traffic symbols will be there, right? So that will have different shape. Here it is 28 out of into 28, right? That will have 32 into 32, I guess. So if you go and search and practice, either you work on this I have solved it. Uh, if you go for traffic signal means, you take the data set and you check how you can able to solve that type of problem. Okay.